there, it's Mrs. Nelson. We're going to talk a little bit today about static electricity, the law of attraction and repulsion, and conductors and insulators of electricity. So you've probably all walked across the carpet in your socks, probably in the winter when it's a little bit drier, and maybe you went to touch a metal doorknob and you got a zap or a shock. That shock that you get comes from the same place as lightning in the sky, and the power used to run your microwave, and the power used to keep the lights on in your car. So this first section we're going to do, you've got Part A booklet, either pick it up at the school or you've got access to it online. It's static electricity. There's a Part B booklet that you'll get in a couple weeks, and that's on current electricity, so the second half. So this phenomenon was first recorded around 600 BC, so that's before the Common Era, by a Greek philosopher named Thales. He noticed that when you rubbed amber, again that fossilized tree sap, with fur, both the amber and the fur attracted small pieces of straw and wood shavings. So objects that attract materials after being rubbed are said to be charged. Since the charge remains stationary or static on the surface of the object, it is called static electricity. So the word static is the same as stationary, means you're not moving. So the law of attraction and repulsion says that two like charges will repel. So up above like, I've got positive and positive, or negative and negative. Those are the like or same charges. They will repel, which means to move away from each other, and unlike charges will attract. So the unlike would be positive and negative, negative and positive, or even positive and neutral, or negative and neutral. Those are unlike. So two charges that are the same move or go away from each other, and two charges that are different will come together. So again, if you can, you have this diagram in your booklet on page 9, if you can use arrows to show how they'll move when they get close to each other. So positive and positive, those are like or same charges. They're going to repel or move away. So I've got the arrows kind of showing that each will move away from each other. Positive and negative in the middle, those are unlike charges, so they're going to attract or move together towards each other. And negative on the bottom are same or like charges, so they're going to repel. So if we flip to the top of page 10 and we talk about explaining static electricity. Electricity is the movement of electrons. So when we talk about an atom, which we reviewed a couple of days ago, you've already learned in chemistry about protons, electrons, and neutrons. The protons and the neutrons are stuck in that nucleus. They cannot move. But electrons do orbit and go around inside the around the nucleus. So they actually are the particles that can move. So electricity, we're going to talk about how those electrons move. So we kind of need to look at what's going on inside of an object in terms of the protons and electrons. Some atoms hold their electrons more strongly than others. So insulators are materials that keep the charge on the spot that they're rubbed on. So materials that keep that charge on the spot are said to be insulators. So an insulator holds on to its electrons really tightly, so it does not allow the easy movement of electricity or electrons. The atoms in the substances that act as insulators hold their electrons closer to the nucleus, and the protons inside the nucleus. Oh, I think that should be neutrons. Oh, let's change that. Oh, that should be neutrons. Sorry about that. If you can just change that for me. Closer to the neutrons and the protons inside that nucleus. So they hold on to their electrons really, really tightly there. So if the electrons are held tightly by these substances, they're not going to give up or donate their electrons. So if we rub a balloon on our hair, like in this picture here, the balloon would build up negative charges. Balloons are made of latex rubber. They're insulators. They hold on to their electrons really tightly. So wherever you rub that balloon on your head, that balloon will actually rip the electrons off your hair, but they'll stay right on that spot that they're rubbed. So if we put it near a wall would originally be neutral, but what happens is we have all these negative charges built up on the surface of the balloon, so that will repel away those positive charges, or sorry, repel away the negative charges, because only negatives can move, negative charges, and leave this kind of part of the wall slightly positive so that balloon will stick to the wall. I've got an activity for you coming up where you're going to go online if you have access and look at a couple of simulations about this. So if an atom does not donate its electrons, it'll gain them during rubbing. So therefore, electrons will not move. The electrons will not move and electricity will not move through these substances. Most nonmetals are insulators. So materials like rubber, glass, and wood. So if you want to, beside these pictures that you have in your notes, write the word nonmetals. That would be great. And there's that diagram of the balloon again with the, when we rub the balloon on our hair, it'll pick up electrons from our hair, but because the balloon is made of an insulating material, it's not going to donate any electrons. They'll just stay right on that spot where they're rubbed. We put it near the wall, and all the electrons in the wall are repelled away. And that slightly positive front part of the wall is attracted to that negative part of the balloon. Conductors are materials that allow charges to move freely through the material. So materials that allow charges, to flow freely through are said to be conductors. So a conductor allows the easy movement of electricity or electrons. The atoms in the substances that act as conductors hold their electrons loosely. Loosely held electrons are likely to lose electrons during rubbing. Therefore, electrons will move and electricity will move in these substances. Most metals are good conductors, such as silver, copper, aluminum, and gold. The human body is also a good conductor. So again, you've got these pictures. If you want to write something like metals beside it, that would be great. Some conductors lose electrons more easily than other conductors. Some insulators lose electrons more easily than other insulators. So there are both examples of good and poor conductors. This describes their ability to allow electricity to pass through them. So electrons that are loosely held by an atom will conduct electricity easily. So you've got on the top of page 11, it says fill in the different types of materials using the video called 2 Conductors and Insulators. So I've put that in your folder as well. So what I want you to do is while you watch the video, under each of these, write examples from the video that are written down that are good conductors, that are semiconductors or insulators. Before you pop off this and do the video, there's just one more set of notes to fill in at the bottom of page 11. So I'm just going to flip it, and then you can go and watch that video and fill in those examples of conductors, semiconductors, and insulators. So conductors lose electrons, and that makes them positively charged, and insulators gain electrons, making them negatively charged. So that's just notes to fill in at the bottom of page 11. So that's all for today. Go on and write that up. Watch that video and then carry on to do the exit slip that's posted in assignments. Have a great day.